In this video, I want to discuss how to solve logarithmic equations. Furthermore, you can also use this technique to solve exponential equations. The reason is because you can always convert exponential equations to logarithmic equations. The technique I'm going to show you essentially involves simplifying the equation so that you have a single log on each side of the equal sign, both logs with the same base. Okay? So let's do several examples to show you what I mean. So the log to the base 2 of 7x plus 6 equals 3. Now let me repeat. We want to get a single log on both sides, both with the same base. We've got a log on the left side, so let's rewrite the right side as something that's equal to 3. How about the log of 8 to the base 2? Okay, now once you have that situation where you have a single log on both sides and they're both the same base, now you can drop the logs. Okay, the only way that two logs can be equal with that have the same base is if their arguments are the same. In other words, this for this equation to be true, 7x plus 6 has to be equal to 8. Okay, and so you can simplify that much easier equation and you get 2 over 7. Now you're going to have to plug in your candidate solution to the original equation to make sure it works. Sometimes what you think is a solution might not actually be part of the domain. Okay? So that's how it's done. Now would you please try to solve this one? Log to the base 3 of 2x plus 4 equals 2. Pause the video and try to solve that now. Okay, I'll go ahead and do it. So I'm going to rewrite the right side, put it in an equivalent form that has a log to the base 3, and that would be the log to the base 3 of 9. That's equal to 2. Okay, so the only way those two logs could be equal is if the arguments are equal. So 2x plus 4 equals 9. So 2x equals 5, x equals 5 over 2. Okay, and let me remind you, you have to plug in your candidate solution to make sure that that indeed is a valid solution. Okay. Now, you may need to move some terms around before as part of the work you have to do to get it to the form that you have a single log on both sides with the same base. So try this one next. All right, so I'm going to first move the 5 to the other side. Then I'm going to divide both sides by 4. Okay, now I'm going to try to get the right side into an equivalent that has a log, a natural log. So that would be the natural log of e to the minus 3/4. Therefore, 5x equals e to the minus 3/4. And so x is 1/5 e to the minus 3/4. Okay, and once again, make sure you plug that in and see that indeed that satisfies the original equation. All right, not only might you have to shuffle numbers around, you might need to use your log formulas to combine logs into a single log. So here's an example of that you can try. Okay, pause the video and try to solve this one. I'll go ahead and do that. Ln of 12 over x, because a difference becomes a quotient, ends up with being the natural log of a quotient. Okay, so this implies 12 over x equals 3, cross multiplying 3x equals 12, so x equals 4. And plugging that in, we see that indeed that satisfies the original equation. Okay, can you do this one as well? The log of x plus the log of x plus 5 equals the log of 6. Try that one, please. Okay, I'll go ahead and solve this one now. So log of x times x plus 5, because a sum of logs that leads to a product, equals the log of 6. And by the way, I didn't write the base of the log, so we understand that that implies the common base of 10, FYI. So now the arguments have to be equal, so x times x plus 5 equals 6. X squared plus 5x equals 6. X squared plus 5x minus 6 equals 0. X plus 6, x minus 1, that factored form is equal to 0. So the only way that can be true is if x equals minus 6 or x equals 1. Okay? So those are the two answers, right? No! If you got that, if those are your two answers, that is wrong. Okay, why is that wrong? Remember what I said about having to check your candidate solutions to make sure that they're part of the domain? Notice that the minus 6, you can't plug it into the first log of the original equation, because the domain of the logarithm function for any base doesn't accept negative numbers. So we have to throw that out. So the only solution is x equal to 1. All right, I want you to be one of the people that doesn't fall for that trap. All right. And now I want to close by showing you how to turn certain difficult exponential equations into logarithmic equations that you can solve. All right. Now, if you can turn an exponential equation into a form where you have a single exponential on both sides with the same base, you know that the exponents have to be equal. All right, but that's not always possible. At least not easily. All right. For example, do you know how to exponent you have to raise 10 to equal 50? All right. So what I would suggest, instead of trying to go down that route, is simply take the logarithm to any base of both sides. So for example, natural log of both sides gives, so on the left side it simplifies to x times the natural log of 10. And so x in this case is the natural log of 50 divided by the natural log of 10. Notice how we were able to solve a difficult exponential equation using logarithms. Okay, so you try one now. What about 2 equals 1.05 t? This might come up, for example, in a compound interest in an investing problem. You have $1,000 in the bank growing at 5% interest. You want to know how long before you have $2,000 in the bank. Okay, so how would you solve this one? How would you solve for the number of years until your money doubles at 5% annual growth? All right, so I'll be quiet now. So pause the video and try to solve this. Okay, so I'll go ahead and solve it now, taking the natural log of sides. And again, the base that you use doesn't matter. Natural log of 2 equals the natural log of 1.5 raised to the t. So the natural log of 2 is t times the natural log of 1.05. So t is the natural log of 2 divided by the natural log of 1.05. That's how many years you have to wait to double your money. All right? Let's close with one more example of this involving the natural base. .7 equals e to the minus 0.4 times x. Solve for x, please. All right, I'll go ahead and do that now. So the natural log of both sides. And this one is nice because the natural log of e raised to anything is just that anything. In other words, the exponent. So the natural log of 0.7 equals minus 0.04x. So x is the natural log of 0.7 divided by minus 0.4.